Okay, so this is our first binary problem. We have a set of 5 projects here, and we want to choose a subset of these projects to maximize our profit, or in this case, net present value return. So we're basically trying to maximize the values in row 5, but we have certain constraints in terms of cash and in personnel. So each of these projects requires an investment, and we have a limited resources of 150,000, and it requires personnel, and we have a limited resources of size 12. So we have this kind of program here. So we're trying to maximize our overall profit. Each one of these variables is a 0 or a 1. So if we don't select any projects, then all x1, x2, x3, x4, x5 are all zeros. If we, for example, selected just the first project, then x1 would be a 1, and this function altogether would be 180,000. Everything else would be multiplied by 0. And then it's exactly the same with the cash limitations and the personnel limitations. Each of these values is multiplied by either a 0 or a 1 if we are investing in the project, and a 0 if we don't choose the project. So let's kind of set this up now. So we have our project selections here. Now basically, the return is just going to be as per the equation we just went over. It's just going to be the return times the project decision. And the fact this is going to be the same for the cash and the personnel. So let's just, for the project decision, let's just put $1 on that as we're going to drag it down. Oh, and what did I do wrong? Oh, I removed my 11. So we have B5 times B11, and then we do Control D. And then, for example, for the personnel, we have Control C times Control 11. And then we do it for all the other projects, so Control R. So just imagine this last project, cash used, is the cash requirements times the project value. Oh, and we didn't add a 0 to that. So then we can kind of basically calculate the totals. So we have the sum on our return, which we're trying to maximize. And we also have the sum, the cash used, and the sum personnel. Okay, and that really just sets up our project. This is a very simple problem. This is what comes from the class of problems we call knapsack problems. It comes from this idea that we have a certain number of items that we can put into a bag or a knapsack, and they have a certain value, in this case the expected return, but there's also constraints, such as if we go with a knapsack analogy, there's weights constraints. We can't put too much in our knapsack, and there's maybe area constraints. We can't have them too big. But in this case, it's cash constraints and personnel constraints, but it's essentially the same problem. So let's go to data, let's go to solver. And so we want to maximize our return by changing all of these variables, subject to our constraints. And it's basically these guys are less than or equal to the actual resources. Now, this is still a linear program here, but we want to have these as binary. So let's just add, as we had an integer constraint, we can also have a binary constraint. Okay, so let's click solve. And there we are. We invest in projects 1, 3, and 5. This gives us a total return of $530,000, and we utilize $140,000 in cash, and we use 10 personnel. Let's just see what happened if we added another project. we improve our profit, but then we go over the available resources, both in terms of cash and personnel. So that's our optimal solution. You can see that none of the constraints are actually bound. Let's just have a look at the answer report. You can see here that none of these constraints are actually binding constraints, either the cash used or the personnel used. So we'll just get rid of that. And that was just a very simple example of an kind of a knapsack, what we call a knapsack assignment problem, but the reality of just picking a certain set of objects to maximize the value from those objects, subject to certain kind of resource constraints on those objects. That's not what I want.